Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why sometimes you go with your gut feeling, and other times you carefully weigh all the options? Well, this new study might have a clue, digging into how we choose our thinking strategies. Today we're talking about the bias-variance trade-off and how it shapes the way we make decisions. Sounds complicated, right? But stick with me, because it is actually a really neat idea that explains why sometimes simpler is better, and other times, going deep is the way to go. Think about it. For ages, scientists have debated if we humans are super rational or, well, a bit flawed. We all know we make mistakes, right? You might have heard of cognitive biases, those weird ways our brains sometimes trick us. But then there is another idea called ecological rationality, which suggests these flaws or biases might actually be helpful in the real world, especially if our environment is messy and uncertain. This idea leads to the concept of fast and frugal heuristics. These are like mental shortcuts that are really good at adapting to our environment. The researchers here are looking at whether we humans consciously or unconsciously pick the right thinking shortcut or strategy based on how tricky or uncertain a situation is. At the heart of this is something called the bias-variance trade-off. Imagine you are trying to predict something. Bias is like a consistent, systematic error. You are always a little bit off in the same direction. Variance is like your predictions jumping all over the place, being super sensitive to small changes or random noise. The formula here, Mississippi E bias 2 plus variance, is basically saying that the total error in our predictions comes from both these factors. If you have a super simple strategy, it might have low variance, meaning it is stable, but high bias, meaning it is consistently wrong. If you have a super complex strategy, it might have low bias, meaning it is usually pointing in the right direction, but high variance, meaning it is all over the place. The trick is finding the sweet spot. This idea has been used to explain why sometimes simple rules, like just looking at the most important piece of information, actually work better than trying to consider every single detail. When information is noisy and unreliable, a complex strategy that tries to use all of it can get thrown off by the noise, leading to high variance and bad decisions. A simpler strategy, by ignoring some of the messy details, might have more bias but also much lower variance, making it more reliable overall in uncertain situations. The big question for these researchers was this: have people actually been testing out different strategies and learning which one works best when things are uncertain? Or have they just been trying more complicated things because they think they should, even if it makes things worse? Previous studies show that we learn to pick strategies based on whether they've worked well in the past. But what about when we haven't gotten direct feedback on outcomes, but instead we've learned about how reliable or unreliable the information itself is? That is what this study aimed to figure out. To test this, they created a clever experiment. They wanted to set up a situation where a simple strategy like focusing on just one piece of information would be the best bet in one scenario, and a more complex strategy like looking at all the available information would be optimal in another. Crucially, they wanted to manipulate how reliable the information was. Without giving people direct feedback on whether their job hire was good or bad, they wanted people to learn about the environment's uncertainty. So, what did they do? They presented participants with a hypothetical job hiring task. They had to choose between two candidates for a job. The candidates had 3 different skills, and participants were given information about these skills. Here is the key: the information about these skills wasn't perfect. It was measured with some level of error or noise. They were told that all 3 skills were equally important for the job. The true skill levels were generated, and then noisy measurements of those skills were created. The twist was in how much noise there was. In one group, called the low noise condition, the measurements of 2 of the skills were pretty accurate. In the other group, the high noise condition, those same 2 skills were measured with a lot more error. The first skill was always measured perfectly in both groups. This setup allowed them to mathematically figure out what the best strategy would be for each level of noise. They simulated lots of candidates and lots of measurements. Let's look at what the computer simulations showed them. As you can see in this figure, the simpler strategy, using just one attribute, had a constant bias and no variance. That makes sense because that one attribute was always measured perfectly. The more complex strategy, using all 3 attributes, had no bias on average. But its variance went up a lot as the noise in the measurements increased. And what did that mean for accuracy? This graph, panel D, is the really important one. It shows that when there was low uncertainty, meaning the measurements of attributes 2 and 3 were pretty good, using all the attributes led to more correct decisions. But when the noise went up, when the uncertainty was high, the simpler, single attribute strategies started performing much better. This beautifully demonstrates the bias-variance trade-off in action within their simulated task. Now, what is different about this study compared to others? Many past studies looked at how people learn which strategy to use based on getting direct feedback about whether their decision was right or wrong. Here, participants didn't get that kind of trial. By trial feedback, they only learned about how reliable the measurements of the skills were themselves. This is key because it means they had to rely on understanding the structure of the environment, not just the consequences of their actions. They recruited 117 people for the study. After some participants were removed for not paying attention, they had a solid group to analyze. The experiment had two phases. First, a learning phase. Participants saw a candidate's interview scores for different skills, and then they could reveal how that candidate actually performed on the job. This was repeated for 20 trials. This phase was designed so they could learn about how unreliable the skill measurements were. Then came the decision phase. In this main part, they saw information about two candidates for the job, but without the actual job performance outcome. They had to make a hiring decision based only on the potentially noisy interview scores. They were told they'd get a bonus at the end for making good decisions, but no immediate feedback on each choice. This was important to ensure people couldn't just learn this strategy worked. That one didn't on a by trial basis also. They carefully set up the trial so that the simple strategy and the complex strategy would actually recommend different candidates, making it clear which strategy they were using. And what did they find when they looked at the participants' choices? Drumroll, please. The results were exactly as predicted by the bias-variance trade-off theory. Participants in the high-noise condition, where the information was less reliable, were much more likely to use the single-attribute decision-making strategy. In fact, 44.4% of the time they used the simpler approach. Compare that to the low-noise condition where the information was more reliable. Here, only 19.4% of participants leaned towards the single-attribute strategy. The statistical analysis, using what is called a logistic mixed effects model, showed this difference was significant, meaning it wasn't just a fluke. The p-value for this was very low, like a tiny flukometer reading. This suggests that indeed people adjust their strategy based on how uncertain the environment feels. So, did this adaptive strategy selection actually lead to better results? Absolutely, in the high-noise condition where people use the single-attribute strategy more. This strategy was correct 75.3% of the time, while the complex strategy was only correct about 24.7% of the time. Conversely, in the low-noise condition, the strategy that involved averaging all attributes was correct about 72.6% of the time, much better than the single-attribute strategy at 27.4%. And overall, the participants in the study did better when they were in the low-noise condition compared to the high-noise condition. More impressively, when you look at how accurately participants made their choices, they were more accurate than if they had always used the single-attribute strategy, and also more accurate than if they had always used the averaging strategy. This indicates that their adaptive shifting between strategies was indeed paying off. They also looked at how long people took to make decisions. You'd expect that using more complex strategies would take longer. And indeed, participants responded faster in the high-noise condition, where the simpler strategy prevailed. However, they were also surprised to find that people actually took longer to make decisions when they used the single attribute strategy compared to when they averaged. This might seem counterintuitive, as averaging should be more computationally demanding. The researchers suggest this might be because people who are generally faster thinkers and better at processing information are also more likely to use the more complex averaging strategy. So, the speed difference might be more about individual differences in cognitive speed than the complexity of the strategy itself in this specific setup. So, what is the big takeaway from all of this? The researchers provide the first strong evidence that people can adaptively shift their reliance on different decision strategies based on environmental uncertainty, even without direct feedback on outcomes. This aligns with the idea that we are not just bound by limited cognitive resources, but that we also intelligently navigate the bias-variance trade-off. They believe that both the bias-variance trade-off and the cost of using our mental energy work together to shape how we select strategies. In their experiment, the focus was heavily on the bias-variance trade-off because the task wasn't overly demanding in terms of computation. But in real life, if a task requires integrating a huge number of attributes, the sheer effort might make a simpler strategy better, even if the environment is low in uncertainty. Remember that surprising finding about response times? They acknowledge it is a bit of a puzzle. They think it might be due to the fact that strategy usage wasn't directly controlled. People who are naturally faster at processing information might be more inclined to use the complex strategy, leading to faster times when they use it. despite its complexity. What is next? The researchers point out that they only looked at two specific strategies, a very simple one and a straightforward integration of all attributes. In reality, people might use strategies in between these two extremes, like using weighted averages or more sophisticated methods. They also suggest future work could use techniques that track thoughts in real time to get a deeper understanding of the mental processes involved. Another important point is that uncertainty can come in many forms. This study focused on uncertainty about the reliability of our information inputs. But there is also uncertainty about which pieces of information are even relevant, or uncertainty about our ultimate goals. Future research will explore how these different types of uncertainty influence our strategy choices. Ultimately, this research is a significant step in understanding how we make decisions. It provides compelling evidence that we aren't just stuck using one mode of thinking. Instead, we adaptively shift our strategies, opting for simpler, less error-prone approaches when the world is uncertain, and embracing more complex methods when the information is more reliable. This highlights how important it is to understand the uncertainty we face in everyday situations, moving beyond lab settings with perfect information to the messier, more complex open world, where most of our important decisions are made. So, the next time you find yourself making a snap judgment or painstakingly analyzing a situation, remember the bias-variance trade-off. Your brain might just be smartly adjusting its strategy to the uncertainty around you. What do you think about these findings? Does this explain some of your own decision-making habits? Let me know in the comments below. And if you enjoyed this dive into how our minds work, please hit that like button and subscribe to RUBIN'S Mind Lab for more fascinating research insights. See you next time!